afternoon. I'm Lavender, a senior Earth observation data scientist from Frontier SI, based in Melbourne. I'm based in Perth, by the way. Today I'll be speaking about the EO Insights tool developed by Frontier SI Insights team for open Earth observation data management and analysis. So Frontier SI is a not-for-profit social enterprise focused on solving big problems using our expertise in spatial area. I guess a bit motivation about why we developed this EO Insights tool. So the motivation for developing this tool stems from the need for a standardized solution that can handle data loading and analysis across multiple digital Earth platforms, for example, the digital Earth Australia, Africa, and so on. Having data agnostic and reusable functions would simplify the process of working with diverse data sets. It would then allow faster development for projects, removing the need for specific platforms or cloud environments. For example, if you ever use the digital Earth Australia sandbox. So what is the EO Insights tool? It is a Python-based tool designed for Earth observation data management analysis. At its core, it's using Python and ODC stack to access spatial temporal asset catalog, what do we call stack, catalogs to access products such as Landsat Sentinel data from digital Earth platforms like digital Earth Australia, digital Earth Africa, NASA Earth data, and more. Users can configure customized metadata via the configuration files, which would enable flexible data handling. The tool allows for data querying, loading, and analysis without relying on a specific data platform. For example, as I mentioned, the sandbox is a good example. And the tool is currently under the Apache 2.0 license, making it both open and adaptable for a wide range of EO applications. The tool currently includes functionalities to interactively select an area of interest from the base map in a Jupyter notebook, for example, and load Earth observation data sets using the selected areas and other parameters within just a few lines of code. And it allows you to apply cloud masking on the loaded data as well and calculate some commonly used band indices. At the moment, we are still developing this tool, and we plan to add more features to the tools to include the ability to load from other data sources, like, for example, not just the data sets on the cloud, but also local files. We would also like to expand the functionalities to include commonly used machine learning functionalities such as training data sampling, image segmentation, and so on. So that's just like a bit about this tool. I put in the link of the repository, the GitHub repository of the tool if you'd like to know more about the tool. In the repository, we've also included some notebooks to demonstrate how you can use the tool to load the data, and some user examples as well. For example, in the screenshot is showing a very prototype workflow of how to load the data and how to do object-based classification, for the southern bellfrogs in French Island, I believe. So those would help you to understand how to use the tools in your real projects. That's all about the presentation, but thanks for listening and delaying.